Hello everyone. So today we're going to talk about enclosures for the Prusa printers. For the Prusa MK series printer. So it works for the MK3, MK3S, MK3 Plus, MK4, and it even works with the ones that have a multi-material unit. And I'll show you how I do that. So this is what we're building today. Uh, Why do we need an enclosure? Well, if your printer is inside of an enclosure, the temperature, the ambient temperature of the air is warmer, there's less currents, and you're much less likely to have warping of your parts. What happens if you have a very large part? You could have they could lose adhesion to the bed if they cool too fast, and so if you keep the enclosure if you keep the printer in an enclosure at the correct temperature, and that's going to be about 35 to 40 degrees with this enclosure. 35 degrees for PETG, and I reach about 40 some degrees, 40, 41, 42 degrees for ABS. There's a tiny bit of a few gaps here. I've never bothered taping them or doing anything about them. That doesn't seem to matter. 40-degree ambient is good enough. The Prusa MK3, this is an MK3S printer. The electronics has never suffered. I've printed about 3,000 hours for this one inside of an enclosure, a similar enclosure that I have over there. This new enclosure was for my Prusa MK4. See previous videos if you're interested. I did a full review of the MK4, and the only important part is to have the um, PSU, the power supply unit, outside of the enclosure. They don't like high temperatures. And of course the Raspberry Pi if you're driving your MK3 or MK4 using Octoprint, and you probably should. You can drive your printer from anywhere in the world. So now that I've showed you what we're doing today, let's do it. So we're gonna start from almost from scratch. I'm going to start with just the legs installed, and we're going to assemble this whole thing. So I made some room for the enclosure. So finally I found some landing spot. I already have two MK3 printers, so I'm actually going to put the new enclosure next to the other two printers. So this is that's the final resting place for the new LACK enclosure. So every time I get a new Prusa printer, I buy a LACK IKEA table, and they're about $15. Actually, they used to be $15. I think now they're about 20 or so dollars for the black ones and 15 for the white ones, or maybe 15 for the white ones and 18 for the black one. I can't remember. And this is what it looks like when it's completed. So I'm going to actually do the same for this last table, and my last printer is going to end up in it. And this one has the MMU unit. And for each one of them, for each one of the printer, I have a separate LACK table. So that's what my MK3 S Plus looks like, and that's what my MK3S Plus with the MMU unit looks like, and that's what well, that's gonna be my MK4 printer is going to land right there. So this is its final spot. My setup looks like this. This is actually looking at my ceiling. This is all the filaments. So I have about 20 kilos worth of filament that are hanging from the ceiling with those rods, and there you go. So my MMU unit fits out of those 10 filaments spools, and my MK3 and my MK3S feeds out of those 5 spools. So normally people go to IKEA, they buy a LACK table. This is it. This is a LACK table. And once they have their LACK table, what they do is they actually pile it on top of another LACK table. So basically this would be the first LACK table, and then you would have the legs of the second LACK table on top, and the top of the LACK table would actually, you know, be opening and closing. It's a bit complicated. I think that the design I came up with is actually a bit simpler. So what I do is I invert the LACK table. So this is normally the top of the LACK table, of course. And this is going to go on a table. So I already have the table. So I don't want a table. What I want is I want an enclosure. So I'm going to actually drop this on a table. So this thing is basically the top of the LACK table. And what I did is I punched 4 holes through the top of the LACK table, and I bolted the legs to the legs of the LACK table to the top of the LACK table. So now I have an inverted coffee table, and of course the inverted coffee table has nothing underneath. It's a normal table, so you could not use it as a table any longer. I'm gonna put 2 doors here, and I'm going to put 3 walls right there. And at the end, what I'm going to do is I'm going to put a sheet of plexiglass. The sheet of plexiglass at the top is going to be transparent, so in fact I'm going to have a better view of the Prusa printer. All the parts that I'm going to use today are actually on Prusa on printables.com. So as I'm publishing this, what I'm going to do is I'm going to as well publish the models for the LACK table. So I cheated a tiny bit. So there are two grommets that I'm going to use as to hold the hinges on the LACK table, and I already glued them. So it's already done. And the other thing that I did is I glued the tops. So the tops have 3 parts. It was making it simpler to print. There's a top part. It's actually very nicely printed, and with a groove. And then at the bottom there are 2 protruding cubes, and they're gonna go right there. They're going to actually close. They're gonna close the table. So it's gonna be something like this. So I'm gonna install this right there. I'm gonna have another one. Huh? I can get it. I'm gonna have another one right there. Okay. No, wrong one. Another one like that. Okay. So the ones for the doors, they have a notch because the door needs to be able to move on its hinges. So I'm looking for. So this is gonna be on this side, and that one is gonna be on that side. So see this thing here. So I have a post right there. The post has two functions. The first one is it lets the door move, and it holds the hinges of the door. So I have those tiny thingies that I'm gonna screw to the top, and this is gonna go right at the top of it. There you go, and we're done. So now we've installed we've installed the hardware for the door. So this is going to look like this, and of course we have a symmetrical one. Where is it? Oh, it's already over there. Alright. So here you go. So it's gonna be like yes, so. So the groove here is going to be holding the top plate. So the top plate of plexiglass is gonna be held by those 4 grooves, as well as these top holders. So there's gonna be one on each wall. 1, 2, 3. All right, so we're gonna do this. So again, I've already glued this together. I think it's easier. All right, so this is gonna go here, this corner. That one is this corner. All right, so this goes here. I have 3 of them. It's gonna go at the top. So again, that's the top holders for the. All right, that's the bottom of the doors, top of the doors. All right, and all right. So you need screws. So I got number for 5/8 screws that's gonna be used for this hardware. So these ones are in the corners, and these ones on the side are gonna be held by screws. So you need 6 and 6 and 6 and 6. So 6 times 6. No, actually 3 times 6. So 18. You need 18 plus the magnet that holds the door. That's 2 more. So you need a total of 20 screws to go around. And for these guys, I use simple coarse drywall screws in 1/4. You don't need to go much further, because when you actually drill through the legs, you're actually going to you're gonna be through the wood very, very quickly. This is just a piece of plastic, and there's wood only at the top and bottom. There's almost no wood in a LACK table. That's why they cost $18, I believe. All right, so we're going to do this. We're gonna put 8 screws, and of course they're gonna go through those boxes. So the 8 screws are going to actually hold the 4 corners. And I'm starting with the top, because it's going to allow me to know where these parts are, and these are going to be holding the plexiglass walls. I need to say something about the plexiglass walls. I'm going to put a link on the screen when I did this video. I got them from Printed Solids. There are a couple of companies in the United States that actually do plexiglass cut on demand. I don't know in Europe, but in the US it's really easy. So you say, I want plexiglass for a LACK table for a Prusa enclosure. You just Google this and you're gonna end up on a Printed Solid. This is really cool, actually. They have cornered this weird market. So, all right. So now we're going to install the 3 walls. I'll finish with the doors. So first the 3 walls. So again, mid height, I'm gonna have this guy. At the bottom, I'm gonna have this. And I've already created notches inside of my plexiglass. So I have beautiful pieces of plexiglass. Right. Okay, so I'm gonna start with this one. All right, so that's the first one I drilled. I'm not even going to bother removing the plastic on the plexiglass. I'll do that at the end. So if you do not cut small notches at the bottom for those corners, what's going to happen is that those corners are going to push on the plexiglass, and the plexiglass is gonna bend. It doesn't bend a lot, but it's just visually annoying. So my first couple enclosures, I didn't do that, but now on these ones, I just go, and with a Dremel I remove a tiny bit here. and a tiny bit in the middle where the this plexiglass holder is going to be. So that's what I'm doing right now. I'm measuring where the so I don't need the screws anymore. So I'm measuring where the hardware is going. So obviously I want this to be lined up, something like this. And what I'm going to do is I'm going to put a tiny bit of blue tape. I'm back with blue tape. So of course the blue tape is the ultimate weapon of the 3D printing guy. If a 3D print doesn't stick to the bed, that's what you add to the bed. You don't need these sticks of glue that they give you with the printers. All right, so that's lined up. So I'm visually looking down. I could measure, but I'm lazy. It's actually better like this. All right, so that's how it's gonna be lined up. Okay, now we need to take care of this guy. All right, I should have put the tape before, but so on the other legs I'm gonna put the tape before I insert the sheet. All right, so it's gonna be right there. So this is the result. So right along the leg, we've created a small ledge, and then we can now put our first sheet of plexiglass. And this hole has not been drilled yet in the plexiglass, because we're going to actually do that at the end once the plexiglass sheet has been installed. Now time has come to install the plexiglass sheet. Okay, one more thing, I cheated. So I created I put a hole here for the plate that holds the main plexiglass, horizontal plexiglass at the top. But I also drilled another hole for the webcam support. So if you have a webcam, you can use this as a webcam support. And I drilled 2 holes, and those 2 holes are going to hold the Voronoi Raspberry Pi case. Okay, so this is how it goes. Yes, so. All right, so at this point, we have to put those things, which are, I'm gonna guess, let's call them a F shape. Right? If you look at them like this, they are F-shaped. So we're gonna put those Fs here, and they are used to hold the top plexiglass. So the top plexiglass holds by the 4 corners, as well as those 3 holders, as well as this piece which goes on the frame of the printer, and that's gonna hold the plexiglass in the middle. So I use this, and the plexiglass is not attached in the middle, so it's actually free floating. Oh, and last but not least, we still have the camera. The camera is gonna go on this side, and we have the Voronoi from the Raspberry Pi, and so the Voronoi from the Raspberry Pi, which stores the Octoprint software, which controls the printer remotely, is going to go on the side, on the outside of the box. I guess it would be easier if I... Okay, so I'm gonna put this right there, and that's gonna come on top. And so that's gonna be the controller. So it's basically a Raspberry Pi with I use the Raspberry Pi 3B because I have a bunch of them, and that's plenty enough to run Linux and Octoprint, and that's going to control the printer remotely. So the doors are gonna go ESO, and at the top and bottom of each door, I cut some notches, and the notches are going to be used to hold the hinges. So something like this. There's a tiny notch, and that's going to hold the doors. On both of my other enclosures that were made using the same model, I've actually glued the hinges to the doors. So I'm going to do this, and we'll be back, I guess, in half an hour. I'm gluing them with epoxy. It's very simple, just a tiny bit of epoxy, top, bottom, and a tiny bit of epoxy on this one as well. So this one's gonna look like this. Same story. Okay, so if you're wondering, I did the notches using a Dremel. So if you don't have a Dremel, Axo is gonna do it, I guess. But be careful not to break the... So here you go. So we're almost done. So we're going to install the two doors. I didn't know I was going to hold the two doors in place, so I decided to, well, the epoxy is actually I was going to say drying, as the epoxy is actually hardening, but I think the solution is to actually install the two hinges. So to install those pieces, I'm using M312 screws. So at the bottom, right there, we're going to install a magnet, and the magnet is going to hold the door closed. There you go. So that's the magnet. The magnet should be identifiable. And by identifiable, I mean the two magnets leave some marks when you insert them. So all right, I'm going to hold the magnet in place because I do not want to have the magnet move while I'm drilling. All right, that's perfect, right? They're closing here, and that's where I'm going to put the hardware. And so the screw that's going to hold the hardware is going to be held by the magnet, and so that's how the door closes. Alright, so we still have to put screws here, and here, as well as at the top of each one of those. But I think we should remove the plastics now. So of course, the heatsink was getting exactly in the way of the Voronoi shape. so I had to cut around the heatsink. I installed the Raspberry Pi inside of its new enclosure, and I used two of the screws that hold the motherboard are actually protruding, and I'm going to use these to screw this Raspberry Pi on the side of the enclosure. Okay, at this point, we're done. You're probably wondering why we need this. Well, we need this here. So this is that's the holder. It's gonna hold the plate at the top. Okay, why do we need this? Well, that's to allow the filament to move freely when it's fed from above. I'm going to show you in about 2 minutes. I'm going to show you my setup. So I have spools hanging from the ceiling on roller bearings, and I'm feeding the printers from the top, and I'm feeding them through this that tiny gap here. And that's how the top plate looks like. There you go. So it's 22 by 22 inches, which is whatever in centimeters. There you go. And that's why we need those things. They're actually holding the top plate in place. There we go. And this guy here is actually holding the top plate in the middle. Wow. There you go. So thank you very much for watching this video, and I'll see you in the next one. And the next one might be the MMU3. I hope to receive it soon, and when I get the MMU3, I'm sure I'm going to do a review of it. I had mixed feelings and experiences with the MMU2S. It's working, but sometimes not working. It's a bit finicky. I'm hoping the MMU3 is going to be perfect. It's rumored to be, so we'll see. Thank you very much, and see you in the next one.